invoicing, billing, whatever. Your CRM system handles all your customer contacts, marketing campaigns, and so forth. And the e-commerce system is your web shop or online services and other things you need. Now, you want to build a web app where your sales team, they want a simple way of viewing their order status and history and use that while talking to their customers. Now, all of these systems have different APIs on top of them. They're like different sized Lego blocks. If you ever got that present from your grandmother that bought somewhere that they bought micro blocks or something, which looks like Lego but is not, it doesn't fit. And you had all this nice Lego and it wouldn't fit and it was mismatched. And you were like, thanks, Grandma. And like, throw this shit away. They're not really compatible. They're different. Different ways of interacting with, different ways of querying, but we're going to assume a happy life here. And when they at least they have defined some APIs for you to use. You don't have to go sifting through an old database with 4-letter table names. So we have this web app that has different parts. It has one status for the orders, history, customer view, and all of these things need access to different kinds of data in one or more services. And the project is delivered, and it was delivered as a tremendous success. Sure, it took a while to develop these integrations, but it was budgeted for. The project was delivered on time. It was under budget. Everyone was happy. In fact, the sales team is so pleased that they want something similar, but not quite the same, in a mobile app. Because they're often on the road and they need this information. So they wanted some more features as well. And there's a different context. So we can't really reuse everything. And it wasn't really a topic when you were building the web app, which is an ASP.NET, and the mobile app wants to be built in React Native. So we can't really reuse a lot of the stuff here. So we redo a lot of the work. And they all know that this is not ideal, but there are constraints. There's time constraints, budget, and there's that consultant that was in here for 6 months doing the last app, and he's out, so nobody knows what that happened. No long-term thinking, and over time, change becomes very difficult. And as we all know, the only thing we can rely on being constant is change in this business. And this is just a simple example. If you add a few more backend services and a bunch more apps, you'll quickly see that this is not really a desirable situation. This is the kind of stuff that makes Mr. Newman sad. He's also named the world's most sad dog, the world's saddest dog. So what does any business want more of today, except money? Everyone wants more money. But the next best thing than money is things that let you make more money faster. And that's usually 3 things. There's innovation. We want to have the options to innovate. We want to experiment. We want to try new things. We want to fail fast. Heard that expression? Does this work? If it doesn't, tweak it a little bit. How does it work now? And people want to operate on the mantra that if you're standing still, you're falling behind. In order to have that, you need to have some form of agility. Doesn't it work? Well, change it. Try something else. Put this out there, do an experiment, get feedback, tweak something, shove it out there again, and iterate on top of that. Embrace change. Heard that expression before? It's really hard to embrace change when you're dealing with that 3-letter German. And you want speed. You want to reduce the time to market. You want to see something happening, respond to that. You want to react to your competitors. Even better, you want to be ahead and beat them so they can react to you instead. All of these things are hard to do when you're working directly on top of a backend system. Even in the best of cases, like our example, what we need to do is to build this capability outside the backend systems and on top of them. And there's perfectly good reasons why we can't have all those things in our backend systems. You do not want people tinkering with ERP or payroll system every day and optimizing that for customer satisfaction. We want to optimize those systems for stability and safety. But we also want these other things. So what we do is that we make 2 lanes. We make a slow lane for stability and a fast lane for innovation and experimentation. This is where our API comes in. It divides those systems between those 2 lanes, but also enables how the communication between those 2 modes of thought or modes of speed. And I pretend to be an engineer, so I brought data to back my statements up. Not much, but there's 2 case studies from MuleSoft did, which is, considering the source, MuleSoft makes API systems, but they implement in company APIs. In Siemens, they were 50% faster, twice as fast when delivering their MVPs, which means that you can get those experiments going a lot faster. BP, 2 times faster app development. That cuts your development costs in half, because most of the cost is personnel, which is a significant impact. So this is not something you might want to do because it's technically nicer. It actually can have real business value and real speed value in your company. So how do we do this? Well, we're going to need some tools, and we're going to need some process or some a direction. So we're going to start from the bottom and work our way up. The basic problem we're struggling with here is that all our backend services have their own language. And as the Tower of Babel story, that makes it impossible to communicate properly and is really hard to build on top of that. The cool thing about these conferences is that there's a lot of people from different parts of the world that come together. I've been to conferences where we had a group with people from Sweden, from Netherlands, the UK, US, Canada, Romania. It was an Israeli guy there. And we could all talk together, and as we're doing right now, because we spoke a common language, English in our case. We decided that that's what we're going to speak. Everybody knows that, and we're going to communicate on that. And that's what we need. We need a common way of communicating with the other services, a single language, not a programming language, more of a language of definitions, a language of how to describe a system so that other systems can understand our description. So we need some kind of way of describing these systems. OpenAPI is one of those languages or description format. OpenAPI can describe an HTTP-based API, which means a web service. It allows you to describe your API, your endpoints, your operation, responses, parameters, the lot. It used to be called Swagger. Some might remember that name. Now it's renamed and rebranded as OpenAPI. The important part is that it's machine readable. It has a structure to it that can be interpreted relatively easily by a machine. It can be a JSON or YAML, depending on what you want, or how big a fan you are of significant white space. Some of you, Dylan, might be old enough to remember WSDL files, which is sort of the same thing. And you can say a lot of bad things about SOAP, but WSDL files was not one of those bad things. They were kind of cool. You point in that WSDL file, boom, there's your client. Now, don't worry if this is hard to read or it seems obscure. You're not really supposed to read it, but we're going to take a little close look at some parts of it. Here's an endpoint /users with an allowed operation you can get. It could have been post, but in this case, it's get. It can respond with a 200 OK. That's good. And it can return an array of strings. And right about that, it says it's application JSON. So these parts here describe an endpoint /user where you can do a get call. It's no parameters defined. It will respond with a 200, and then it will give you JSON with an array of strings. That information is enough to generate clients. There can be a lot more information in here that will enable you to generate more information, but you can consume that description file from various tools and automatically generate clients for various languages. You can, for instance, generate both a C# client and a TypeScript client from the same OpenAPI file. The OpenAPI file can include information like the type names, field names, and so on and so forth. Our example was super simple, but it will allow you to generate a full set of types, classes, APIs, methods that are named intelligently because you have made some effort to start with, right? Now, there's lots of tools for doing this in various languages, and the actual generation is not as interesting in this context. The important thing here to know is that OpenAPI can be used to generate clients automatically. What is interesting, we're going to look a little bit up, is different ways of generating the Open API file from a service. The details are different in various languages, but the general themes are similar. In the .NET world, there's three or three major options of generating your file, depending on the definition of generating. One option is adding code to your application. It will generate an Open API file. In this case, we're using Swashbuckle, I think the API is called. There's two major ones on .NET, Swashbuckle and NSwag, where you add a Swagger generator, which will register an Open API generator that inspects your routes, your properties, parameters, methods, classes, and generates an Open API specification on top of that. Then a little further down, you can insert your middleware that allows you to, that will output your JSON file or Swagger file. And you can also register a UI part, which will give you UI for your Swagger file or your Open API definition. It's usually a tool that lets you examine and play with the API. I'm going to do a short look at that. This is one of our services we have currently. It looks like this. There's different endpoints grouped by controller. So we have a My Page, we have notifications, payment, and there's a bunch of more as well on this particular server. You can expand those. You can see whatever parameters they need. This one doesn't need any. There's no parameters. Scrolling down, you can see different responses it can do. This one will return a 200 success. It will return an object with 3 strings to it, or an array of objects with 3 strings in each, a type, a form ID, and a status. It can return a 401 unauthorized and a 403 forbidden. So this describes the different expectations a client can have from this endpoint. Top right, there's a try it out button. Clicking that will allow you to execute your API. It will actually do a call against your API. You can see the a curl example that you could use from the command line or terminal, and you get a response body and the response headers. This one returned 3 items and some response headers. So it's a really super easy way to explore an API and get a feel for what it does without having to ask Albert down in the basement, who manages the ERP system, what all those 4-letter table names actually mean. The other way is inspecting your compiled assembly. Looking at the code, basically decompiling your assembly, looking at that and generating the Open API document from that. The advantage here is that you can do this with an existing application without actually changing any code, redeploying anything. It has various degrees of success depending on how your application is compiled, but it can be a really useful avenue. It usually requires more tweaking in config files, and you can have a little bit less options, but it's a perfectly viable option, especially to get started easily with existing code. The third way is to go the other way, is to start by crafting your Open API document. There's lots of tools online that lets you do this easier than just writing YAML or JSON yourself. And then you can use that document to generate the API. This has several advantages because there are some things in the standard that is not easily expressible for Swashbuckle and tools like that to pick up. But this is not really a talk about Open API. So if you want to learn more about those things, read more about it. I suggest the Microsoft Docs pages or the Open APIs. Now, assuming we have a bunch of Open API in place, let's go back to our 3 services. Where should we start? Well, we'll make sure we have an Open API interface on top of each service. Most major legacy systems or enterprise systems do not offer this today. It's going to come. They're going to be better at it, but right now they don't. If they do, that's super. So let's make an open API service on top of these. You probably want to start with query operations, but eventually these things will evolve pretty much into CRUD operations. So how do we do this? Well, we can make small microservices that expose an API and proxy those calls down to the backend system. So each system here would have one or several microservices, could have, depending on the context and domains. And there's also various tools that can talk to different enterprise systems and legacy APIs and expose an open API. Depending on your environment and where you're at, you can do this with little or no code. Let's look at a small example. For instance, Azure Logic Apps, which is a no-code solution where you can define connectors and data between them. Favorite tool of the economy guy in my company, he loves Logic Apps. They have a pre-built SAP connector. You define your input, send a message to SAP, define your output, and it will automatically generate an open API file that you can consume from somewhere else. But it can really be anything that's able to talk to your backend system and respond to an HTTP request. So Logic Apps is a nice no-code solution. It could also be a bespoke web application running somewhere. It could be some serverless functions. It could be a bunch of orchestrated microservice containers running in a dual distributed Kubernetes cluster, whatever you want, or just plain old virtual machines. It doesn't really matter. The important thing here is to establish a common way of discovering and interfacing with these services. HTTP APIs documented by OpenAPI. And to get that, you do whatever you have to do to make that work for the different kinds of services. Get that open API on top here. Now we have that foundation going. We have our different backend systems, and we have an open API interface on top of that through some kind of service or some kind of solution or interface. What you do not want to do is eat the whole elephant at once. You do not sit down and look at your whole range of backend systems and, okay, let's start on the left, and then we'll drive through here and get all these things done. You build what you need when you need it. Perhaps we're building a front end that needs to display some information about a customer, but that information is spread across two backend systems. So working with the demands around customer information, we build two services, one for the ERP system and one for the CRM system. These services only cover a small part of the underlying system, small vertical slice if you want. We do not expose the entire ERP system, which would be a huge undertaking. Just the little part that we need for that particular project. And then as a new project comes along, that will take another part, and then another part, and then we move along like that. And then we can build more services on top of this, combining several services. So customer information is often spread across different systems. Some information in that system, some information in that system. We never really know. So we can get a common view here and say, this is what a customer looks like. We establish that as a fact. What we're doing now is that we're establishing a company-wide ubiquitous language, saying, what does this mean? What does a customer contain? When I use this word, what does that mean in all these different contexts, depending on where it comes from? So ERP system and CRM system might have different names for the same actual data. And moving up in the stack, we can make this the same names. So, and then we can build more services that can consume a nice and unified data from our customer service without having to care about how these underlying systems are structured. It doesn't matter anymore. It just says, here's a customer. We have defined what a customer looks like in our company, and that's all the order history has to care about. And then we can build more services on top of that again. So all of these top layers, except for the bottom layer, all of these tops are an open API surface, easily consumable. So building these APIs becomes relatively easy compared to what it used to be. The grunt work here is now done. And the work involved in building clients on top of this here, that's also reduced greatly. You can get a C# client generated from the web API, make web pages. You can get a React Native mobile app that consumes the mobile API with a TypeScript client. Both clients will have strongly typed data objects, strongly typed API clients, making it super easy to consume these APIs and whatever data they have. And now we get that speed and agility part and innovation where you say, okay, what if we had this thing? I don't know. Let's build a small prototype and find out if it helps. And but isn't that hard? No, we just consume some API, throw up a mock-up and a little experiment, and there we are. And we can also start layering our cake here. At the bottom, there's a data layer. Then we have a persistence layer. Here you need insight and knowledge about the underlying system. On top, that's where we define our ubiquitous language. One thing means the same across the entire company. There's not customer first name, customer surname, customer given name anymore. It's just we define that customers have first name. That's it. The business layer. Now you don't have to know the underlying systems anymore, how they work. Here you need knowledge about the actual business and its processes. The ubiquitous language goes here, right? Who owns what happens if this goes on, and so on and so forth. These are the business processes. We are now abstracted away from the ugly underbelly of the beast, which is the three-letter German and his friends. And we have some form of presentation layer where you combine several sources into views specialized for each app, client, or domain, or situation or context. This can be done by client basis, or you can have some relatively standard ones. It doesn't really matter. It's up to you and your situation. But for instance, a mobile app, you might want to send less data over the wire, so you're going to drop a few fields and skip some resources than you would in a different kind of app. If you're a GraphQL fan, this is where you'd put that endpoint as well, maybe crossing down a little bit down in the business layer, because you can do a little bit more of that depending on your complexity and your actual needs. But then you would have GraphQL endpoint, which would consume different open API services, and then could be used for your mobile app, your web app, and whatever. It's very helpful to think of your API in terms of these layers, because these layers have different characteristics. We talked about how they have different knowledge needs, but they also have different characteristics. Velocity and agility will increase as you go up the stack. The top is where you do your innovation, your experimentation. You change things around. You try a little bit here, you try a little bit there. As you're moving down again, things become more rigid. But instead of having that hard border, which you crossed immediately before, there's a gradient. You can have different levels of agility. This enables the things we talked about: speed, innovation, agility. It also enables things like autonomous teams, where teams can be more self-sufficient, more self-organizing, saying that, oh, we want to, in your business somewhere, they can sit down, have a couple of smart developers or super users even with no-code solutions, which can easily consume open API like Power Apps, and say, oh, what if we have this and this and this and combine this and show it this way? Do you think that would help us? I don't know. Let's try and find out. And a team somewhere in a corner of your company can do that experiment without having to involve a whole bunch of chain up and chain down in two different departments and Albert in the basement. Now, this can easily look complicated, even if these boxes have the same surface on top. And if you leave it as purely individual parts, it will get complicated and complex. Next move here is to try to make this into more of a unified surface, which can be controlled in a more orderly fashion. This is what's called API management. API management is having a tool or a service of some kind that helps us with most of the things we talked about. This could be a homegrown Kubernetes platform that you have a whole bunch of governance and procedures and helper tools to put your stuff into it and make it happen. That is fine. I know several companies who have built that themselves. This API management, there's also different tools that will do a lot of this for you. What they'll do more specifically is they will connect to your backend systems. They will expose them as open APIs. You can do translations from one standard to another. You can combine multiple APIs into one. And most of these things are done through configuration, not necessarily development, which, if you manage to keep yourself within the box a tool like that offers, can give you a lot of speed and flexibility within that framework. It also does a few more things that makes it worth looking at, such as authentication and authorization. You can handle that at the edge of your API, and you don't really have to care about it going further in, provided your system is correctly set up. You can do that auth at the edge, and any service further in can just assume that that thing is handled. You can do rate limiting, making sure that nobody screws up and hammers your ERP system 100 times per second. You can do analytics, how are your APIs being used, what's not being used, what can be deprecated, what can we remove, what do we really need to keep. And you can do caching. There's, in any company, there's lots of data which are almost static that never really changes much. There's no need to hit the backend system for all those requests. We can cache those at the edge. It also makes for more performant clients instead of going all the way down to the 4-letter tables in the database. So how would that look? Well, we'll take a brief look at a system that one particular product that I know, which is Azure API Management. There are several products out there. I mentioned MuleSoft earlier. They create a product that does a lot of this. I'm going to talk about Azure API Management because that's the one I'm familiar with. But they all have there's several different ones out in the market. What you do with API management is you import an existing API. You have to have somewhere that it can read data from because it doesn't have data on its own. It will connect to several different sources, including OpenAPI. When importing, you specify a path to your specification file, to your JSON file, point to that file, and then it will iterate through that like we looked at. It will find the endpoints, find the operations, and it will list all the different operations that you have or that it found. There's some API for a conference tool. Those are all the operations defined in the backend's open API specification, hopefully supported by the backend as well. What you can do next is that you can add what's called policies or processing. You can add policies to both inbound and outbound processing to modify both the request and the response. There's lots of things you can do here, but a policy is a definition of things you want to happen or check on the way in or out. You can set HTTP headers, you can search and replace text in the request or response, you can set rate limits, you can hide fields, add fields, combine multiple APIs into one. You can have multiple policies that are executed in sequence. You can have logic and control flow. You can respond to errors. And this becomes a really powerful low-code tool to gather and define your APIs. You can even add C# code in here. Depending on your backend system, this could cover both the presentation and business layer and perhaps even down to your data layer, depending on what the backend system looks like. For instance, if you have a backend system that has a SOAP API, which is not easily consumable from a JavaScript application, for instance, Azure API Management can automatically convert between a SOAP API to a REST or HTTP-based API. It has a developer portal, which is really useful for larger organizations, where you as an administrator can define your APIs, you bundle them into products, and users can then sign up for those products. This can be open to everyone if you're that kind of shop. It can be subject to approval or locked down with Azure AD. And a user could go in and start a subscription to one or more products. They can see the documentation for the API pulled from the Open API file, pretty much like we saw earlier from the Swashbuckle UI, but same kind of thing, but in a different place. try out the API from the browser, just like one would expect to use with an open API system. They can self-subscribe to products, manage their own subscription keys. Again, this is very beneficial to autonomous teams. It's self-service, no bottlenecks. So a team can decide, oh, we have an application here. It would be really helpful if we had access to that kind of data. Well, let's go into the management portal and see what's there. And you can find, okay, here's an API that looks useful. I can take a look at it. Yeah, this will give us what we want. So register, subscribe to it, get a subscription key, you're off to the races. Know when an IT needs to be involved. You don't have to talk to anyone to get access or different passwords. If you've done your work right, everything is still access controlled, and nobody has to bother Albert down in the basement with his 4-letter tables anymore. There's much more to API management. I could do a whole talk just about that, but that's going to be another session, maybe next year. But know that these kinds of tools exist, and they can be really powerful for getting quickly up and running with something. Whether you use that tool or you build a bespoke thing with lots of microservices, you now end up with a unified surface for your enterprise. This tool has an open API surface, making it easy for us to consume this API in our apps. Now, if you're making your own backend systems, you have your own bespoke backend system for doing domain-specific things, don't forget to import those into your API gateway as well. Offer open API surfaces, add them to your API layer. It will remove some work for you, like caching, rate limiting, authentication, but it can also make your stuff and data available to the rest of the company through a standard and open, easily consumable interface, which can enable collaboration and innovation that you didn't think of before. One important thing to remember or figure out is who owns what data. What particular piece of data is owned by who. And not just who owns the customer, but who owns the registration date for the customer, who owns the address, the name, different fields. Because in a system, a large company, this information, the unified customer view is going to be spread on different systems, and there's going to be duplication. If you have a customer that has an address, it's probably present both in the ERP system for work orders and the CRM system for customer follow-ups and account management. Who owns the address, right? This is what's known as master data management, and can, in many companies, be a really, really hard problem. If you have multiple systems, you're going to have duplication, and you need to know what is the primary source. If you don't know what the primary source is, what source is defined as a master or always correct, you have a hard time giving a trustworthy source to the rest of your company. Also, if you're going to take updates, you really need to have this figured out. Because up to now, we only talked about query. What happens when we want to put data back into the system? Well, there's several ways of doing that as well. And what you end up with will be based on your environment and your systems. But there's 3 main ways of doing this. 1, let the customer service sort it out. Customer service already knows where it's pulling the various pieces from. It's not a huge leap to let it know where to put what back. It knows that the ERP has the address, but the CRM customer has the email address, for instance. And it will take those data, put it there, take that data, put that there. Take an update different systems accordingly. The other option is to decouple the customer service by updating downwards. What it will do instead is send out an event. We'll pick that up, some kind of message bus or transport or service bus or whatever, but somewhere that can pull up a message and can forward that to different subscribers. So both the ERP and the CRM customer services are interested in customer updates. They'll get their updates delivered, and then they will update further down as needed. We can also send updates to different systems that are not our backend system to let them know what happened, which can be a powerful addition to an API system, having some kind of event-driven bus that various systems can connect into. Many enterprise systems also have eventing systems built in, and they can notify when information is changed from that system. It's not a given that every update has to go through your API wall from the different apps. These ERP systems and CRM systems, they have their own powerful interfaces, and updates are going to happen there as well. So you need to figure out when something is updated in those systems, how do we make sure that data duplication doesn't occur or master data is correct? This is a task you've probably been doing already if you have these systems, because you have that data separate. But they have their own eventing systems that can propagate information. These are, you also have the traditional ways of these systems interacting, which are database copies, flat file exchanges, imports, exports, and so on and so forth. Which version you want will depend on what kind of model you're most comfortable with, how much logic is involved in showing things into the backend. And we're not going to talk about how to build an event system. That's slightly out of scope, but I'm happy to talk to anyone who's interested in that after the talk. So where do you start? Where do you go from here? If you're writing any APIs today, make sure you have open API files for them. If you're making a system that has data that should be shared or could be shared within the company, and it has an API, make an open API interface. It is not hard, it's not a lot of work, and it will make it a lot easier to integrate your system later. Even if you're not using it for anything else, now that you have the first building block, build that open API proxy if you're talking to a backend system. So if you're having an application that today is talking to a backend system, which is kind of weird or odd to talk with, doesn't have an open API interface, make that proxy. It's a small sliver of an application. If you're making a web application, you can, or similar, you can even build it into the application, just make it a separate part. And now you have a start. You have that building block going. It is important not to chew over too much. Start with what you need. Base your building on business needs. Business says we need this data. Okay, where does that go? Here's that piece of data. We're going to take this data and expose and build on top of that. Don't sit 6 months building a huge proxy and not going to need 80% of it. I suggest you do a proof of concept with a cloud managed API gateway or some management tool. It is dead cheap to get started. Figure out quickly, is this something for us? Will this help us? It makes it really easy to get a structure and a governance in place early when you have a small number of APIs. And then instead of coming into a chaos and then trying to lay some governance on top of that later. And master data management, it is super important. If you don't know who owns what data, there's no way of trusting that the data you output and give on to others. That's it for me. Feel free to reach out either on Twitter or email if you have any follow-up questions coming up or later. Any shower thoughts that come to mind in a later occasion. If anyone has anything they're wondering about right now, then go right ahead.
Excellent stuff, Glenn. Thank you. And yes, folks, please unmute yourselves if you have questions. We can have actual discussion going on here in the mysterious online world of digital conferences. I thought that was really good. And thank you so much for speaking and being part of it all. Question from Matt in the chat. Having API management does not lead to a single point of failure.
Sure. Just as having one ERP system leads to a single point of failure. Having API management if you're going for Azure API Management, is a hosted service that is pretty well distributed and has all the. It's not a box sitting there. So, and the same rules follow. If you want to make your stuff highly available, then you invest in making it highly available. You have you have double machines, and do all that stuff. If you basically have a cluster. If you want to run MuleSoft or something like that internally, you don't install that on a single machine. You install it on a bigger machine. Yes, you gather all your eggs in one basket, and then you make that basket as robust as you need from a business standpoint. And this is, of course, a trade-off between never having downtime and paying all your money to manage that. Did that answer your question, Matt?
Yes. We're gonna assume it did. It did. Awesome. Any other questions, folks? All right. Well, we're keeping track one open because in about 15 minutes, we're going to be closing out the conference here with some